Hi folks, so the questions we have in front of us guys here today are the 2018 Section A core questions from the higher level paper, and as you can see there's 4 questions on the paper and you have to do 3 of them as always. Okay, so what we're going to do is we're going to take them individually one by one, and we're going to start with this one up here on the top left and working my way from A1 to A2 and so on. Okay, so I'm going to zoom into this one here now. So for question A1 guys, it says the 3D graphic shows a bicycle shelter. Okay, so you can see a 3D little graphic here. The drawing shows an incomplete diametric projection of a similar shelter using the axonometric axis method. The horizontal plane is also included. And it also says part A, complete the axonometric projection of the bike shelter, and then it says a line joining Y to B represents the straight line path of a football. Show the point of impact of the ball with the glass roof in the axonometric view. Okay, so basically first of all we're going to focus on part A here, where it says complete the axonometric projection of the bike shelter. So first of all, we're doing axonometric projection here, but specifically this is actually based on a diametric plane. So a diametric one is where, if you see this little triangle in here, it's kind of like an isosceles triangle. It is where 2 angles are the same. If you have isometric, it's where 3 angles are the same, whereas there's also trimetric where no angle is the same. So as you can see here, we kind of have the side elevation here, okay, the end elevation, and then we have the front elevation here as well. And we're going to use the 2 of these to complete our axonometric view down here. Okay, so try not to get confused. You can see here, obviously we have an image here. This is kind of to help us out. So we've got this front bit here, we've got the bit in the middle, and then we've got the bit at the back as well. And you can see there, obviously this bit here is the top bit, then we've got the middle bit, and then this bit here as well. Okay, just to be able to find all of those. So to be able to complete them, what we're going to do here is just a little bit of sliding set squares. So using your set squares, line it up. Obviously you're projecting at the angle that they've given you. It's actually perpendicular to the plane line here, the axonometric plane. So it's perpendicular on this side and perpendicular there. So I'm just going to project that as best I can there now. There we have it. So at this point here, I'm going to locate where the middle line is. And you can see the middle height guy, which is this guy up here. That's here in this position. So I'll project that across, and that will show me where it is hitting over here. Okay, and now what I'm going to do is I'm actually going to focus on the top surface of it here first of all. Okay, so this kind of top face here. So I'm going to project down. It's just a case of working through it slowly. All of these points here. So this will be, this one here, the lowest one, is actually at the back. So it'll be down there somewhere. Then it'll be on the top one as well. That top one has actually helped me out straight away, because I can see this one here is already there. So I'm going to heavy in that now. That's kind of the top one right there. And then it's a case of finding the one at the back, which I know is down here. So once again, projecting down parallel, just set up your set squares in the correct orientation. So I'm just going to continue this line out. I know I could have continued that, but just trying to be as accurate as I possibly can. And this guy right here connects up here. Now I'll heavy in this guy at the back. So that's that back edge there, and likewise now I can put in the middle one. Okay, because we know the middle one is hitting here, I can now put in this guy as well. Okay, so that's all the top of it done. I've got this, this and this. Now it's a case of finding the actual little kind of bike rails here where you would put in your bike. Okay, and we've obviously got 5 of them that we have to put in. Okay, actually sorry, before that I'm going to get where it hits down here at the bottom, and also down here, just to be able to get that edge. Forgot that. So I'll line it up once again, sliding set squares, and then same down here. So we'll extend that down here. That'll give me this one. Likewise with the back, and it will show me the 2 points right there, and make sure I have the exact one. Yep, Okay, so there we have it. That's there. Obviously the side's done now, the top done, and I've got to get the inner section now. Okay, so to find the middle section, I'm going to project down all of these points at once, just to have them done once again. So I'm getting the inside parts in here. Make sure as accurate as possible. Neatness is important. I'll come down a little bit further just to have it long enough. And I think these ones are already projected down, so that one's okay. And now I'm going to project down these guys. I have my line there, I can use it. So this one's just going to come a little bit further, and this guy also. That guy comes to here. What I actually need to do, and this is important here, didn't take note of this, I will do it now. This guy here has a vertical height, and I'm going to put it in green just so we can see it properly. So using my set squares, I want to line that one up there with that. As you can see the edge here, as we can see the height of this bit portion is a different height to this bit here. Okay, just slide that down there a little bit, and I'm going to put in a vertical height right there. Now, you don't have to do this on the day of the exam, but that height right there that I'm putting in, okay, is important. Okay, so I'm just going to put in a little H there for height. Now that height, I'm actually going to have to map that height up on my other view. I'm going to take that height on my compass, and I'm going to come here and I'm going to mark it on this guy here. Now I could mark it on each individual one, or I could just come to the end one. Okay, and it should work out then that they will be parallel, and it'll give me the points for all of them. Just to be able to find them individually. You can see they're coming out the same height, so that's okay. So all of them, that'll give me a point here, here, here. Okay. So just in completing the first one there now, I'll get back to that. So the height I marked up there, just put that in again. The height from there to there is my H. Okay. So it's just working your way through the problem. And here is the lower end of it, as I said. So it's down here, this one right there. Project that down, and I can actually locate that, and I'll do the first one and then it'll get a bit quicker. So the lowest point, which is down here, matches up, so that's that point there, connects up to this guy, which is here, so I can heavy that in, and then he connects up over here. So you can see there we have the very, very first little rail inside there. So what we have to do now is we just have to find the various other ones. Okay, so sliding set squares for the rest of them. So I'm going to get all the top points first. So keeping it neat and tidy, you can see here I'm actually just marking that down, but you don't have to show it all the time. So there's the next one. Okay, you can see I'm just making a little mark. It's on this line here now, it's just appearing inside there. So this one here, do the last one. Okay, so that's that one, helpful. Now I'm going to find the bottom points, which I can see comes off of this guy, there, here, here, and finally here. And I'll put all of those in, just to have them done. They'll actually should work out almost parallel. I say almost, they should be. Yeah, I'm gonna find. Just the back edges of all my little rails. There we go. So So there's the back edges of all those little rails. Now I want to find the front edges. So same concept. I'm going to project down my base points first. So likewise with this one, it's coming down to this line here. So there's the base one. Just keeping it neat and tidy, as you can see here. So there's the base at the back. Should have marked them actually. Now that I think of it, I should have marked them both at the same time. And finally, I'm going to mark the middle heights as well. So that one came down there. It seems to be on that one. And just for the middle height, it's going to be on this guy. This man. This guy here will be right there, and finally this one there. So now it's a case of heavying in. Okay, could do, as I said, get a sliding set squares, save a bit of time rather than switching around the whole time. And as I said, they should match up. Okay, you can see all of them are matching up. And this guy here, now because the line is so short, sometimes it might be a bit off. Just check it 100%, be happy with it before you do it. There's a little bit off there, so I just need to bring my line in a bit further. So about there. Okay, and as you can see there now, we have 5 kind of bike rails put in and the actual bike shelter done in our diametric plane. Okay, so that's part A done. Okay, so for part B, it says a line joining Y to B represents the straight line path of a football. So you can see here Y, okay, and you can see B here. They've given it over to us here in our end elevation view. We've also got the Y here. Alright, so the Y is here, grand, yeah. And we've got the B here as well. So you can see it here, and we can see it here. It says show the point of contact, or point of impact, sorry, of the ball with the glass roof on the axonometric, okay. So if you imagine the Y here, you can see it's kind of at the back. So it's like it's, if you look at the graphic, it's going off this back stanchion over here. So the Y would be somewhere maybe up there. And our B kind of seems to be in front of it here. So it's like the ball was kind of, if you, the line it was taking was kind of coming through the roof and it was going to land, as in it was starting up here, up above that back stanchion, it was going to come through the roof and it was going to land down here, like that. Okay? And basically what they're saying is, if that's the Y up there, and this is the B, the path that it takes is that, and at some point maybe around there, it's going to hit the glass roof. That's just a guess now, but that's kind of what they're trying to get us to actually visualize, okay? So we're trying to basically create that. So it says show the point of impact, so we have to basically show it here on our axonometric. So in doing that, that's actually not too tricky. It just takes a little, you just have to basically visualize it. So draw it on your sheet. The path is going to take, it's going to be a straight line path from Y to B, okay? And having connected that, we can see clearly where it's actually going to impact our roof, which is right here. Okay, so like any axonometric now, when we just did there, you would project that back at the same angle as we did all our lines to get our little axonometric view inside in here. So I'm going to project that back at the same angle. So once again, sliding set squares. So at that angle there, and somewhere along there, that is where it's going to hit my roof. So it's going to be in there along that line. Now, to actually find that, we have the Y, we have the B. Let's connect them up in this view. And when I connect them up in this view, you'll actually see where the two lines cross each other, which is right here. That is showing us the point of impact. So I'm going to write that in there. I'm just going to write impact point. So not too difficult. If you wanted to find that, technically you could find the B up here, okay, might be in line with this, connect that over and then bring your point back and it'll help you locate it there as well. but we have found it on our axonometric, so that is the question completed. It wasn't actually too tricky, it's just understanding what they're asking you, trying to bring in a real world example if a ball was to hit the roof, okay, and they gave you the path of the ball. So don't get too confused and don't think about it too much, okay, just try and solve the problem as it is, okay. So what we're going to do now, guys, is we're going to move on to A2 at the bottom of the page. So this question A2, guys, it says the graphic below shows a group of fishermen. Okay, so we can see in the little image here, fishermen obviously with their fishing rods, and it says the two fishing rods are represented by the skew lines AB and CD on the right. So we've got the elevation of AB and CD, and then the plan of AB and CD. It says determine the projections of the shortest horizontal line between the two skew lines, and then determine and indicate the distance from this line to the horizontal plane. Okay, this A part is easy, just thinking. And the B part is actually easy as well. It's just they're trying to confuse you once again. They're always throwing in these little tricky bits for an extra 3 or 4 marks. So the main bulk of the marks will come from the A section here, and there's probably maybe 4 or 5 marks for this little B section here, and they're just trying to see, do you fully understand what you're doing? Okay, so sorry there, my pen's just after getting a little bit inky. Alright, so what we're going to do is we're going to get the shortest horizontal distance. So when you have skew lines, what you actually have to do is you have to create a plane. And what we're going to do is we're going to create a plane parallel, okay, to one of these lines, okay, off another. So you could do it 2 ways. I'm going to do it in my elevation. So it's the shortest horizontal distance, we'll get that in the end. We're going to have to take 2 auxiliary views, x1, y1 and x2, y2. So I could go parallel to the line AB from CD, from the bottom of C in this case I actually would, and then do a level line across. If you think of geologic geometry where you kind of get your strike line. And the other way I could do it is I could go parallel to CD from the base of it, or from A, and then do a level line from B. So I'm just thinking how that would work. So CD, get a point up here, so that seems to fit, and then we'll come down here parallel to CD from A. Yeah, that one seemed to work there. Okay, so I'm happy with that. I'm going to stick with that one. So I'm going to parallel to CD in my elevation, from A, and where that is extended up, I'm going to project across horizontally from B. Okay, and essentially what I'm actually finding there is another point. Okay, I've created actually a plane surface. I'm going to just call it E. Okay, I'm going to call that point E right there, and what I'm going to do is I need to now find E in my plan. So if E is here in my elevation, it has to be directly below it in my plan, so it's somewhere down there, and we follow the exact same steps. Okay, so up here these 2 lines were parallel. Okay, and what I want to do now is do the exact same method. So parallel to CD from A. And I'm happy with that, just seems to fit. So there's E in plan, and I know E connects across to B. Now in this one, it's just going to connect across like that, but the difference between this line and this line, they are the same line, but because this line is horizontal in my elevation, it's parallel to the XY line, therefore that makes it a true length in my plan. So that there is a true length, TL. So what we're actually going to do now is we're going to look along the true length, okay, set up an x1, y1 perpendicular to it, okay, and looking along the true length, we're actually going to see that true length, the line from E to B, as a point view, but that means we're actually going to see the line A to B as an edge view, okay, and therefore we'll also get C to D then as well. Alright, so setting up an x1, y1 perpendicular to my true length. So I'm going to swivel that about, and I'm going to set up an x1, y1 just like that there. So just make sure I'm still happy with that. Yep. And now I'm going to project out perpendicular to it from all those points. So B will have to come out a little bit further, something like that. Likewise with D, So now to there. Do the same with C and A, don't seem to come out as far. Somewhere like that. And if you project from the plan, you take your heights from the elevation. So just to be 100% accurate, and what I'm actually going to do, I'm going to line these up and take that height there. That's the height to be. Just want to get the exact vertical height. As you can see, I'm just lining them up with the plan views underneath. So the heights I want are here. You can see I put them in very faintly. So for the first one, I'm just going to take D there. Okay, so for D, come down to D, follow it out to my X and Y1, mark it there. Likewise with the B, out to B, follow it here in plan, out to your X and Y1, and then same with A. And follow A out, and finally C. And unfortunately my compass is with the pen attachment, it's a little bit short, so I'm just going to measure it and just try and get, I can see there it's working out about 5 millimeters, just slightly 4 point something, so try and be as accurate as I can with this. So marking that there, I'm happy with that actually. Okay, so that little mark there, and now I'm going to label all of them. So technically this will be A1, C1, and this will be D1, and finally B1. Okay, and B1 is actually going to be in the same position as E1 as well. Okay, and what you'll actually find is that these two lines should be parallel to one another. So before I always draw them in, I like to check it. So I'm happy with obviously how they're lining up at this moment in time. Just before I draw it in, I usually like to just check, so I slide it up, make sure they're close enough. I'm also happy with that. You can see that everything seems to be lining up there quite well. Okay, so there is our two skew lines, and now they are parallel to one another, and what we want is the shortest horizontal distance. Okay, so to get the shortest horizontal distance, what we're now going to do is set up another XY line next to Y2 that is perpendicular to our X1, Y1. So to do that, use the sliding set squares once again. I like to rotate my set square. It's just how I was taught in school. And there we have our X2, Y2. So perpendicular. Start this out, sorry, no. And we have to project up perpendicular to the X2, Y2 then for all the points. So C2 will be up here somewhere. As will A, as will D, and B. Okay, and what you do to work out the heights for these is, or sorry, the distances I should say, you take your distances from the previous XY line back. So for at the X2, the previous XY line is the X1. So for D, I take the distance from the X1, Y1 back to D, like that. Come out to D here, mark it here. Likewise with B, and once again probably going to come up a little bit short, yes, so B and C I'll have to measure them with my set square. And take it for A, follow to A here, up to this guy. So there's my A, and as I said, simply a case then of I'm going to measure. So for C, it's coming out to be 6 millimeters. So for my C, I'll measure up 6. So lucky with that one. So there's my 6. And for B, it's close enough to 6, probably just a little bit shorter. Yeah, it's going out a tiny bit shorter, it's 5 point something, 5.8 for B. So try and get that 100% accurate. Obviously you'll be using pencils, which makes it a little bit easier. So about there. Happy with that. And what I'm going to do now is once again write in, so B2, this will be D2, A2, and finally C2. So I know A connects to B, C connects to B. There we have it. And where those lines intersect, that point right there is going to actually give us the shortest horizontal line, or shortest horizontal distance, but shortest horizontal line between those skew lines, okay? Because we're looking straight down upon that. So now what I have to do is I have to project that back into all my views to find it up here in my elevation, and it should be horizontal with the XY line, or parallel I should say. So working backwards, we're now going to project back parallel to the way we projected. So our shortest horizontal line, try not to slip as I've been doing. So that will project back there. That's actually going to give me a point on my AB line. And now if I rotate it this way, that point right there, it's important now obviously being very accurate using sharp pens, or pencils I should say. So half a mil makes a big difference here. So to find those points here, I've got the line here on AB and I've got it on CD here, so that's how it would appear in my plan. And this is the making or breaking of it here. So this is the shortest horizontal line, as it appears in my plan, and now I have to find it in my elevation. So just bring up my T-square there. And what I'm actually going to do is, this is where it's hitting on the line CD. It's directly up here, so it seems to be there. And this is where it's hitting on the line AB. And this is the proof of the pudding here. And as I said, where it's hitting here and here, they should be in line with one another. And you can check here, this is a good test of accuracy. Mine seems to be cutting out pretty okay for once, so I'm happy with that. And there we have it. That is our shortest horizontal line. Okay, there is part A done. Now it says determine and indicate the distance from this line to the horizontal plane. This is not hard, they're just trying to confuse you with the words. Here's the line, here's the ground, the horizontal plane is the ground. That is how high the line is up off of the ground. So it's simply a case of measuring the distance from here to here. So using my set square, I'm going to measure it off the 9 here. So 10, 20, 21, 22, it's about 23 millimeters. So whatever your scale is then, I'm just going to put in 23, or you could just put in H for height, okay? Because we're not given a scale, so we don't know is it 23 meters, 23 feet, or something like that. I imagine since it's fishing rods, it's just going to be something like 23 feet, okay? But just put in a H and that will usually suffice as well, okay? So that's the second part of the question done. They're trying to confuse you a little bit there, but once again, don't just think about it. The horizontal plane is the XY line, okay? And the height of the line is up here, so it's very, very simple, okay? Now we're going to move on to A3 at the top right. So for this question, folks, it says A3, the image on the right shows the Salmon Weir Bridge, okay, so you can see the Salmon Weir Bridge here, over the River Moy in County Mayo. The drawing below shows an incomplete elevation of the bridge, and as you can see, we're given the vortex, okay, so that's helpful. That's kind of like, the vortex is kind of like here, this point right there, and we're also given a point on the curve, so somewhere up here around like that, and we're given a focus point I can see. And it says the curved support pillar is based on a parabola. Okay, so you can see it's a parabola which is inscribed in a rectangle. Okay, so this is actually, it's not too bad. This actually goes back to a little bit of junior cert drawing. V is the vertex of the parabola and P is a point on the curve. Draw the parabola. And then part B, F is the focal point of the parabola. The point P is anchored to the bridge surface by 2 cable stays. Okay. The line PF is one cable, so I'm going to connect P to F. That's one cable, and obviously the other cable you can see here. So there's this cable stay here on this side, and there's lots of them on this side. So I assume we're going to have to get the ones on this side over here. The line PF is one cable. The second cable is inclined at 25 degrees to a tangent at P. Construct the tangent at point P and draw both cables. Inclined to 20. Okay, yeah, that's not too bad. So what we're actually going to have to do here is, it says the curved support pillar is based on a parabola. So what we're going to do is, first of all, we're going to draw on our parabola. And I'm just going to measure this to see, do I have any round number. I can see here it's working out to be 80 millimeters. That's nice. I have a nice round number there. That's 80. And this guy here is working out to be, it's 26 and a half. Okay, so that's obviously not a round number. So anytime you have a parabola, what you can do is you're going to divide one of the long side and the short side, or whatever it is, they could be the same, but the long side and the short side into an equal number of parts. The more parts you divide it up into, the more accurate your parabola will be. So in this case, 80, I'm going to divide it, try and make an accurate enough one. I can do 4, 3 would be too little, 4, not bad, I'm going to go with 5. So 80 divided by 5, you can do a little bit of quick maths here on the side. 80 divided by 5 is equal to 16. Okay, so I'm going to measure down 16s, and they've told us V is our vertex. Okay, so measuring down 16, make sure it's accurate there. So there's 16, and 16 plus 16 is 32, plus 16 is 48. And then plus 16 be 64. Okay, because this is our vertex here, we are going to draw on those lines across like this. And my God, I missed that by an absolute mile. I did 11. Absolutely horrendous. So 16 should be here. That one seems to be going straight through it. Okay, so now at this point, what we're actually going to do is, we've divided this line up into 5. We're going to have to now divide this line up into 5. So as I said, it seems to be coming in at 26, 27 roughly. So I'm actually going to just use the division of lines method. So I'm going to extend up here. And what I'm going to do is equal spacings, okay, and I'm just thinking 6, 5 is 30, or 5, 6 is 30. I need 5 spaces. I'm going to do 5/8. Just give me a little bit more wiggle room. So 5/8. So you can see here I've got the 4 right on the corner here, so I'm going to measure back in 8, so that'll give me to 32. Then 32 take 8 will be 24. 24 take 8 will be 16. Make sure I got 16 right this time. And 16 take 8 is 8 as well. Then you obviously have to put the 0. So the last one, I'm going to connect that to the end of the line here. Then I'm going to do a little bit of sliding set squares. And this is, during your drawing, you learned in first year, division of lines, being able to divide a line up into an equal number of parts if you don't know the measurement. Or it is a line, as you can see here, that is not an exact measurement that divides equally into 5. Now, what we have done there is we have divided up this line here into 5 parts. So you can see 1 part, 2 parts, 3 parts, 4 parts, 5 parts. At every one of them, as you can see with the first one, it actually worked out for us already. We've got our point. Now the second one, you're going to connect all of these to your vertex. That's actually going to help you locate some points on your curve. So here's a point on our parabolic curve. First one, the next one is going to be here, next one is going to be here, and the final one is going to be here. So you can see our points right there, there, there. Okay, and at this point then it's a case of sketching in our parabola. So try and do it as neatly as we can, so lightly as you possibly can first. Get the guide of the curve. So there we have our parabola. I'm sure you can sketch it in a little better than I have managed there. So that's the first part. We've drawn the parabola using the rectangle method. Now it says F is the focal point of the parabola. The point P is anchored to the bridge surface by 2 cable stays, and the line PF is 1 cable. Okay, just checking, do I have a protractor here? Of course I don't, I left it at school. So what we're going to do is we're going to connect P to F first of all, and that there is one of these cables. It's like basically I've drawn in kind of like that guy there basically, and what we're trying to do is we're trying to get the other guy in the opposite direction. Okay, that's what we're trying to get basically there. So we've drawn in this guy. So you get marks just for identifying that. Then it says the second cable is inclined at 25 degrees to the tangent. Okay, so what's important here to note is that bit there. It's inclined at 25 degrees to a tangent at point P. So essentially what we need to do is we actually have to find a tangent, and then once we have the tangent we can actually simply draw in our cable. Okay, so even though I don't have my protractor with me, we can still kind of have a crack at it just to be able to explain it. Poor purposes there for the video, guys, so apologies for that. So to be able to get a tangent, what we're actually going to do is our tangent, we'd imagine, is going to look something like that. Okay, it's going to go off and it's going to connect depending on how well I drew my curve, but our tangent is going to look something like that, I would imagine. Okay, and to be able to get the tangent, what we're going to do is, if you think back of during start drawing, anytime you had a tangent to an ellipse or something like that, you connect it up the focal point to the point, and what you actually do is you bisect the angle, okay, between the 2 focal points. Now in this case we have a parabola, and generally you're going to put your line towards the directrix, and what we're going to do is extend my line like this, and the angle created between the focal point and the point and this line here, okay, we are going to bisect that angle, and that bisected angle will actually give us our tangent. And it's all about getting the tangent here, because off the tangent then it tells us that our other cable is 25 degrees off of that. So bisect this angle, nice and easy. Hopefully comes in there somewhere. That's probably a little bit better, so I was timed it out, and hopefully I'm not too bad on this guy. Yeah, it's coming out okay. So just to show you that there, put that one in a little bit darker. So there is our tangent. Okay, so we have our tangent, and now what we know is that it says the second cable is inclined at 25 degrees to the tangent. So using this line, I would put my protractor on point P, and I would measure an angle of 25 degrees. So I'm going to do it as close as I can. So I know I have 30 degrees, so what I'm actually going to do is I'm going to put this on here. I'm going to slide it back a little bit. I want to get as close as I can. This is technically wrong, but it'll do for demonstration purposes. So using your protractor, and then I know I have a line that is at 30 degrees here. Now it tells us 25. I'm just putting, you can see here I'm using a 30 degree. So technically, as you can see, that is wrong. So my 25 degrees is probably going to be in somewhere inside here. So just to use this as a guide, if that's my 30, I'd imagine 5 degrees less is going to be somewhere in about there. Okay, and that angle in there, now I'm not sure if it's 100% accurate obviously, but that is 25 degrees, but what it does is it helps us find our cable, because it's 25 degrees in relation to our tangent at point P. Okay, so apologies for that there, guys, but that is how you would do that question, obviously using a protractor to work that bit out. Okay, so that's that question done there, guys. That was on the topic of conics. What we're going to move on to now is the question A4 at the bottom of the page. Okay. So the last question on this page, guys, it says question A4, the graphic shows a spider cam used for aerial coverage of sports events. It is supported by 4 cables. So you see in these cameras, they come off in, or sorry, they're often above kind of major sporting events, okay, soccer matches, rugby matches, things like that, just to give people a different view on TV. And it says the drawing shows the projections of the cables. So you can see obviously the camera is here, but what's important here is the cables, okay? And you can see we've obviously got the elevation of those cables here, where the camera will be in here at O, but the elevation then obviously is OB, OA, OC, OA and OD, and then the plan view of it here. and what it's saying is find the dihedral angle between the planes OAB and OAD, and then determine the angle between the cables OA and OB. Okay, so dihedral angle, tackle the first part bit here first. So OAB, essentially what we have here is a plane, O to A to B. So we've got this plane here, okay, OAB, and you can see it here in our plan view. We've got that plane triangular surface, and we've also got the other plane OAD, so O to A to D. So this plane here and this plane here. And essentially what we have to do is we have to identify the line that is connecting both of them, and that clearly is the line O to A. So what we actually have to do is we have to get, anytime we get into dihedral angle, you're going to basically have to get the line that's connecting both of them, okay, which is the intersection line, line OA. We need to see that as a true length, and in either view it's not a true length, okay, because OA isn't parallel to the XY line in either view, so we have to actually set up an auxiliary to find the true length. So what we're going to do is we're going to look perpendicular to OA to find our true length, and if we look at it perpendicular in our elevation, what we're actually going to do then is, in our plan, we take our heights from our elevation. So, a little bit of sliding sets for us here. We're going to set up an x1, y1 parallel to OA in my plan view. Slide that up like that, and I'm going to keep it close enough because obviously you're working within your space here. And having set that up, just make sure it didn't slip there. Yep. I'm going to project out perpendicular to it. So projecting out perpendicular, so A would be out here somewhere. Looking at my height there. And D would also be up about there. O is quite low down. And then the last one I need is B, and he's also high enough. Okay, so what I need to do now is find the perpendicular heights for these. So connect O to D, just so I can get that height there. O to A, that height, or sorry, A to A I should say, then O, and finally B, just to be able to get those. I'm basically taking those perpendicular heights there, using my compass. So, taking the height here, that's the height O to D there, taking that, find D down here, mark that up, okay, so that will be D1, and see A seems to be the same height as it, so find A, that will be A1, and B and C, you can actually see, are the same heights as well. So there's my B. Okay, and finally O. Won't be able to get that with the compass, so I'll just measure it. My set square. I want the exact height. You can see there it's working out at about 4 millimeters. So I'll measure 4 millimeters out for O. So there's my O. So there is O1. I've also got B1, got D1, and I've got A1. Now, essentially the one we wanted was the OA one. So OA there, okay, which is the line connecting them, that there is a true length. And the plane I have, there's the line O to D, then O to B, there's O to B, and remember, I'm going to connect these up lightly now. And you can kind of see essentially we have the plane OAD, okay, we have this plane here, OAB and OAD, so there is OAD here, and then we've also got OBD as well, okay, or OAB, oh sorry, I'm after mixing that up, apologies. That should have actually connected over here. That line there, I shouldn't actually have put in that one, apologies for that. Just that line there, I shouldn't have put in that one there, okay, that might confuse you a little bit, you'd have to imagine that one isn't there. So it was the plane OAD and OAB, okay. So now because we have this line as a true length, what we're doing is, it's like we're going to basically put a little eyeball here, okay, and we're going to look in along. So it's like basically I had an eyeball there like that, okay, and what we're doing is we're looking in along our true length, the line OA, to see it as a point view. And when I see that as a point view, I will then see the two surfaces OAB and OAD as edge views, therefore giving me the dihedral angle. So I'm going to set up another X2, Y2, or another auxiliary view perpendicular to my line OA. So this one was my X1, Y1. This is going to be my X2, Y2. So there's OA out there. These actually working out to be quite close to it. And finally B. Something like that. And likewise, once again, just going to take the distances. So when you do an X2, Y2, you take your distances from the previous XY line back. So to find B, I'm going to go to my X1, Y1, mark it out to B here, and find B here, come out to my X2, Y2. As you can see, you need to extend out my line a little bit further. Likewise with A, there's A there, find A here, mark it out. Now I want to find O, mark the distance from O there, which will be the same as A. Oh yes, I what am I saying? Because that'll be in the same position. Apologies, because remember I'm getting that as a point view. And last one then I want to get is the D. So compass is a little bit short for that, using the pen attachment. See there, it's working out to be about 3.8 millimeters, 4 millimeters. Just trying to be as accurate as I possibly can. For D, measuring out the correct distance. So there, yeah, I'm happy with that. So label those. So O1, A1, I'm actually seeing that as a point view. So point view of A1, O1, and if I extend this one out, this is, in this case it's actually A2, O2, apologies. This will be D2, and then up here will be B2 once I have him located. So just to extend that out a little bit further. So that's extended out there. Now the plane OA to D, I'll connect that up, and as I said, we see it as an edge view, which means we're seeing it as a line. And now I've also got the plane OAB, or O2A to B2, because the names or the letters correspond with the XY line. And what you can actually see is we have two edge views. Okay, but the angle, so edge view here and an edge view here, but the angle between them is my dihedral angle. Okay, so that's your dihedral angle right in there. Okay, you could measure that with a protractor, but as we've seen from the previous question, I don't have one with me at the moment. Left it at school. Now the last part, it says determine the angle between the cables OA and OB. So what we have to do here, determine the angle between the cables OA and OB. So OA and OB. So just on that one, what we're actually going to do is we're actually going to have to look straight at the line O to B here, because O to B, we're going to have to see that as a true length, I think, because we have a point view of the line OA here. So when I look at that and I get it as a true length, okay, so I'm looking straight at it in this view, so I'm going to set up an X3, Y3 now. So this is actually setting up a third auxiliary. So this is a little bit tricky, it's really testing your understanding. So this is called an X3, Y3 here, and I'm going to set that up and project out once again perpendicular. So I'm just projecting out 2 points here now. B is on its own, but OA, if you remember previously, that was in as a point view there. Might have gone slightly off the sheet, doesn't matter. And what I'm going to do is, with my compass, same thing, you go to the previous xy line. So in this case my previous one is an x2, y2. So to find the distance for B, measure the distance from the x2, y2 back to B. As you can see, it's repeating itself. And I'm going to measure that distance out here. So I've got B there. Now I'm going to find the distance to O. Make sure it's correct. So that distance there, going to come, remember this is a point view of O2 and A2. So you can see it's gone slightly off my sheet. So I've got B3 here, and I've also got O3. And what I actually have to find is the distance now for A, which is whatever distance back there. It's working out to be 5 millimeters, depending on how much I took. So 5 millimeters out. Right there, that distance right there is A3, and what I've actually got here now is the angle between the cables. Remember, this was a point view of A3 and D3, or sorry, O3 and A3, apologies. That was a point view in this view. What I've done is I've kind of, that point view now, basically I'm seeing it as a straight line, but we're seeing this then as a true length, okay? But the angle in between them, okay, so that angle in there is the angle between the cables OA and OB. Okay, so a little bit of understanding in there. That's a little bit tricky. If I just look at it here, OA and OB, what they've done is they've asked us for that angle in there, and obviously we can't tell it in either of these views, so you have to work your way along. OA and OB. So it was kind of just looking at it, OA, OB, so O to B, O to A. Bit tricky, they were asking you for that angle there, okay? Didn't get it here, okay? But you can see it in this view here, alright? So a little bit of understanding in that, guys, there. And the last one, that there was a little bit on kind of surfaces and plane geometry. Dihedral angle, which comes up every year in some aspect, okay? So that's the questions there, guys, from 2018, the short answer questions. Hope you found them helpful. That's the video done.